So for those of you who saw my review video on the HT Neptune instrument, you'll know that I had an issue when using the 200 milliamp continuity measurement on my winding simulator here. I have the instrument currently set to just normal ohms, and if I put, oh, it's not zero, let's zero in. So zeroed, put him on to resistance range there, and that's 1.2 ohms. Normally the winding resistance simulator should be 1.17 ohms when in delta configuration, and you can see we match there pretty good. We'll flick him to the 200 milliamp test function, and we'll hit the go, and you'll see 6 is bouncing all over the place. We ended up with 7 ohms there, quite clearly out of specification. Okay, so we set up the same test on the U1461A. On this instrument I do have to keep the test button held in, but you can see I'm 1.199 ohms there against the 7 ohms, and this is a 200 milliamp test current on this unit. So in terms of measuring the resistance with 200 milliamps, it does seem to be fine. It just seems to be an issue with this unit itself. What I will just do is pull him out of the way, just flip him to DC volts, and just measure the open circuit voltage. So I need to swap him over, and then we'll go again. So we're 11 volts there being put out by the instrument. Now the instrument only has a 6 volt battery pack, that's 4 AA cells, so yeah, so 6 volts, but we're getting 11 volts out on open circuit. So I would imagine that there's some sort of a buck boost circuit in there to give the increased voltage to get you 200 milliamps. Alternatively, on the normal ohm scale, you see we've only got 2 volts coming out of the instrument, so that's definitely within the range of the battery pack. So the buck boost probably isn't in circuit when using the ohms, but it is in circuit when using the 200 milliamp test function. So I'm just going to have a quick shuffle around, and I'm going to set my oscilloscope up, and I'll just scope the output of this to see if that'll give me more indication of what's going on with the unit when it's measuring the resistance of the winding simulator. Okay, so we've set up our picoscope, which is running underneath the bottom here. Just linked it across the output of the HT instruments onto the winding simulator. I'll put the scope up here. You'll see I will set the trigger to single. I'll set him up. In fact, we've got a times 10 probe installed. So go to 20 volts, and we need to trigger a single. We'll up the trigger threshold. Let's see what happens actually. We'll bring him back across. Scope time. And we'll go. We've actually gone over range, haven't we? So let's put it up to 1 second. Need to go upper range. And we'll go again. Still over range. So we'll just zoom into this and just see what's going on. You can see it's gone up to 50 volts there, hasn't it? So you can see here You can just see quite a bit of oscillation on the output. It's going negative as well. So I'm just wondering if the inductance of this simulator is just reacting with the buck boost circuit and causing it to oscillate, and that's what's giving the measurement issue and leading to the inaccuracy. You certainly wouldn't normally be expecting to see all that kind of oscillation on the output. It should be a fairly straight DC output on there, really. Go up to our times probe. Let's go up. Just see if we can actually capture. Still over range. Yeah, I'm not quite sure. But that's the maximum we can go to anyway, so yeah, you can see it's starting to come into the range of the instrument a little bit. I need a times 100 probe that I don't have. I can't see that that's actually overly representative, it's just oscillations being caused in the output. So a little bit of a mess there, really. Okay, so that's just a little look at the output of the unit when it's measuring with the winding simulator when I'm testing it with a normal motor. It seems to be fine. I get perfectly good measurements that are comparable to the other instruments. It's just when I use it on this winding simulator. So looking at the output of the scope there, it looks like there's some sort of oscillation occurring between the inductance / capacitance of this winding simulator and the buck boost circuit that's being used to lift the supply voltage. Okay, so that's it for this video. Hope you found it useful. Thanks for watching, and I'll see you again in another video.